Hello everyone! Ngayon solve tayo ng mga static rigid problems about friction force, center of gravity or centroid, parallel axis theorem, composite area, product of inertia, and mass moment of inertia. Ngayon, ang una nating i-solve na problem is about frictional force on flat belts. Ang question is, a flexible cable which supports the 100 kg load is passed over a fixed circular drum and subjected to a force P to maintain equilibrium. The coefficient of static friction U between the cable and the fixed drum is 0.30. When angle alpha is equal to 0, we need to determine the maximum and minimum values which P may have in order not to raise or lower the load. And B, when P is equals to 500 Newton, we need to determine the minimum value which the angle alpha may have before the load begins to slip. Ito yung diagram natin. Ito yung 100 kg. Ito yung circular drum. Ito yung radius R. Then ito yung center natin, ang origin. When alpha is equal to 0, we need to solve the impending motion upward. Ibig sabihin pataas. Ang given natin is T2 or tension 2 is equals to maximum value of P. Ito yung unknown natin. At ang given is tension 1 which is equals to 981 Newton. Ang equation or formula na gagamitin natin is tension 2 is equals to tension 1 times E raised to the coefficient friction U times beta. Then we need to substitute the given values in our equation. Maximum value of P is equals to 981 Newton times E raised to the coefficient of static friction 0.30 times the value of beta which is pi over 2. Then 981 times the value of E raised to coefficient of static friction times the value of beta which is 1.602. Then we come up with the answer 1,572 Newton. Ito yung value ng ating tension 2 or maximum value of P. Ngayon, when the impending motion is downward, ang tension, ang given data natin is tension 2 is equals to 981 Newton. Ngayon, ang hinahanap naman natin is yung tension 1 which is the minimum value of P. Ito yung unknown. Ang gagamitin natin na formula or equation is dun sa formula ng tension 2 which is equals to tension 1 times E raised to the coefficient of static friction times beta. We divide the E raised to the coefficient of static friction times beta over to tension 2. Now we come up with the equation tension 1 is equals to tension 2 over E raised to the coefficient of static friction times beta. Then we substitute the given values which is minimum value of P is equals to 981 over E raised to the coefficient of static friction 0.30 times the value of beta pi over 2 equals to 981. We get the value of E, which is 1 point E, and the static coefficient of friction and beta, we come up with the value of 1.602, which is the result is 612 Newton. Ito yung minimum value ng P natin ngayon. Ngayon, dito naman sa letter B, pag given na ang tension 2 at ang tension 1, ang mahahanap na natin yung degree ng ating angle alpha. Ngayon, isubstitute natin yung mga nakakuha nating sagot para makapag-proceed tayo sa pag-solve ng angle alpha. Ang formula na gagamitin natin is doon pa rin sa formula ng tension 2, which is equals to tension 1 times E raised to the coefficient of static friction U times beta. I-divide natin yung tension 1 on both sides. We come up with the equation tension 2 over tension 1 is equals to E raised to the coefficient of static friction times beta. Ngayon, isasubstitute natin yung mga values. 981 over 500 equals to E raised to the coefficient of static friction 0.30 times beta. Ngayon, yung beta natin is yung unknown. Ito yung hanapin natin ang value ng beta. Then we put a which is mean we put a loan on both sides of the equation. We come up with a loan of 981 over 500 is equals to loan of E raised to the coefficient of static friction times beta. We cancel the loan E, and then ang naiwan is yung 0.30 times beta. At dito naman sa left side, loan 981 over 500. We divide the coefficient of static friction 0.30 on both sides. Ngayon, ang naiwan is yung beta. Then we divide 0.674 over 0.30. We come up with the value of 2.24 6666667. Ngayon, ito yung value ng ating beta. Then we multiply it in radians. Kasi yung beta, kailangan naka-express siya sa radians. 24,66667 times 360 over 2 pi. We come up with a 128.7 degree. Itong 128.7 degree, i-minus natin dito yung 90 degree. Ngayon, ang sagot is 38.7 degree. Ang value ng alpha natin ngayon is 38.7 degree. Ang second problem na i-solve natin is about finding the centroid of an area. The question is, determine the centroid and the area of the shaded cross-section. Dito sa figure, makikita natin ito yung homogeneous extruded volume. At itong letter B, ito yung the cross-section of the volume. Ito yung centroid. Ito yung centroid of Y axis at saka centroid ng X axis. Ito yung letter B axis and letter A axis. One boundary of the cross-section is described by the curve x is equals to k times y raised to 4. Ito siya, ito yung curve na yon. The value of k can be determined from evaluating x is equals to k times y raised to 4 at a known point on the curve. At x is equals to a, y is equals to b, giving a is equals to k times b raised to 4, and k is equals to a over v raised to 4. This results in y is equals to b times x raised to 1/4 over a raised to 1/4. Dito siya ngayon sa figure 2, letter A. Ito yung element of dA, which is y of x, tall, and dx is wide. Dito naman sa figure 2, letter B, ang element dA is A, ito siya, A minus X long. Anong dy natin ngayon is yung tall or height niya. Para mahanap natin yung centroid, kailangan natin itong dalawang formula. Centroid of x is equals to integral area times integral of x dx and dy over total area. And ang formula naman ng centroid of y is equals to integral of area times integral of y dx and dy over total area. Para mahanap natin yung centroid, kailangan muna nating unahin na i-calculate yung total area ng element dA, which is y of x. Total area is equals to integral of dA, which is equals to integral of y of x dx. Total area is equals to definite integral of b over a raised to 1/4 times x raised to 1/4 dx. It equals to b over a raised to 1/4 times with the 4 over 5 times x raised to 5 over 4 with the interval of 0 to a. It equals to 4 over 5 times a and b. Ito yung total area natin, 4 over b times a and b. Now, pwede na nating i-calculate yung centroid ng x-axis natin, which is equals to integral of x times y of x dx over total area. Definite integral of x times quantity b over a raised to 1/4 times x raised to 1/4 times dx with the interval of 0 to a over total area equals to 4 times b over to 8 a raised to 1/4 times a raised to 9 over 4. Then dito na proceed tayo dito sa sa baba. B over a raised to 1/4 times sa loob ng bracket 4 over 9 times 9 over 4 with the interval of 0 to a over total area equals to 4b over to 9 times a raised to 1/4 times a raised to 9 over 4 over 4 over 5 times a and b. We come up with the answer 5 over a times a. Ito ngayon yung centroid natin on the x-axis. To compute the centroid of y, we slice the cross-sectional area and create dA is equals to A minus x of y dy. Centroid of y is equals to integral of y times sa loob ng bracket na A minus x of y dy over total area. We substitute the values. It equals to integral of y times the quantity of A minus A over B times y raised to 4 dy over the total area. Centroid of y is equals to A times y raised to 2 over 2 minus A over B raised to 4 times 1 over 6 times y raised to 6 with the interval of 0 to 6 over total area equals A times B raised to 2 over 2 minus A over 6 times B raised to 4 times B raised to 6 over 4 ang total area over sa total area na 4 over 5 times A times A and B. It equals to 5 over 12 times B. Ito na yung centroid of y natin. 5 over 12 times B. Ngayon, ang isosolve naman natin is number 3. The moment of inertia using parallel access theorem. The question is, calculate the moment of inertia of x and y and the radius of gyration of x and y axis for the right triangle shown in figure 1. Dito sa figure, ito yung right triangle with centroid at C. Ito yung centroid natin. Our y1 is equals to 2b over 3 and our x1 is equals to a over 3. Ang triangle is a standard shape. Ito yung formula ng area ng triangle at ito yung moment of inertia at the centroid of x-axis, which is equals to a times b raised to 3 over 36. At ang centroid of moment of inertia at the centroid of y-axis is equals to a raised to 3 times b over 36. Para makuha natin yung moment of inertia about the x-axis, kailangan natin gamitin yung parallel access theorem. The x-axis natin is at distance of y1 is equals to 2b over 3. Moment of inertia at about the x-axis is equals to moment of inertia at the centroid of x-axis plus area times y1 raised to 2. Let's substitute the given data or values. A times b raised to 3 over 36 plus a times b over 2 times the quantity na 2b over 3 raised to 2. It equals to A times B raised to 3 over 4. Ito yung sagot natin. Ngayon, ang kukunin naman natin is yung moment of inertia about the y-axis. Ang equation niya is moment of inertia at the centroid of y-axis plus area times x1 raised to 2 equals to A raised to 3 times B over 36 plus A times B over 2 times the quantity A over 3 raised to 2. It equals to A raised to 3 times B over 12. This is our moment of inertia about the y-axis. Ang result natin dito na na-compute natin ay kailangan natin gamitin para makuha natin yung radii of gyration. The equation of radii of gyration at about the x-axis is equals to square root of moment of inertia at about the x-axis over the area. Ngayon, substitute natin yung value ng moment of inertia at the x-axis, which is square root of A times B raised to 3 over 4 over A times B raised to 2 equals to the square root of 3 times B raised to 2 over 2. It equals to B square root of 3 over 2. This is our radii of gyration at about the x-axis. Then, computin naman natin yung radii of gyration at about the y-axis, which is equals to the square root of moment of inertia of y-axis over the area, equals to square root of A raised to 3 times B over 12 over to the A times B raised to 2, the area of a triangle, equals to the square root of A raised to 2 over 6 equals to A over to square root of 6. This is our radii of gyration at about the y-axis. Ang isosolve naman natin is problem number 4 about the moment of inertia of a composite area. The question is, calculate the moment of inertia of the x and y axis for the t section with respect to the centroidal axis shown in figure 1. Ito yung t section with centroid at C. Ito yung centroid natin. Dito sa figure 2, ito yung the composite section which is divided into two rectangles. Dito sa problem na to, kailangan nating hanapin ang moment of inertia of the composite section by finding the moment of inertia of x-axis and y-axis for each rectangle. Ito yung formula ng moment of x, a moment of inertia at about the x-axis is equals to moment of inertia of 1 at the x-axis plus moment of inertia of 2 at the x-axis, and the moment of inertia of y is equals to moment of inertia 1 of y plus moment of inertia of 2 of y axis. Para sa bawat rectangle, kailangan natin gamitin ang parallel axis theorem para mahanap ang moment of inertia of x-axis. Ang moment of inertia at about the x-axis is equals to x moment of inertia at the centroidal axis x-axis plus area times y1 over 2. Dahil ang y-axis of the T-section coincides with the centroidal y-axis for both of the rectangles, hindi natin kailangan yung parallel axis theorem for moment of inertia of y. Dito, gumamit tayo ng tabular format para sa ating calculation, para organize siya. Ito yung rectangle, area, moment of inertia at the centroidal axis, x-axis, y1, area times y1 raised to 2, at ito yung moment of inertia at the centroidal of y-axis. Rectangle 1. Ito yung rectangle 1 natin, ito yung rectangle 2 natin. Dito sa rectangle 1, 2 times 18 equals to 36 inches squared ang area niya. Dito naman sa rectangle 2, ang area niya is 2 times 18 is 36 inches squared. The moment of inertia of rectangle 1 and rectangle 2 at the centroidal x-axis is 12 and 972. y1 of rectangle 1 and 2 is 5 and 5. The area of rectangle 1 and 2 times the y1 raised to 2 is 900 and 900. Moment of inertia of rectangle 1 and 2 at the centroidal y-axis is 972 and 12. The total of moment of inertia at the centroidal x-axis is 984, and the total of moment of inertia of the centroidal y-axis is 984. The moment of inertia of x-axis or about at the x-axis is equals to the summation of moment of inertia of the x-axis. Which is equals to the summation total or summation of moment of inertia of the x-axis of the x-axis at the centroidal axis I plus total or summation of the area times the y1 raised to 2 equals to the 984 inch raised to 4 plus 1,800 inch raised to 4 is equals to 2,784 inch raised to 4. Ito yung total or value ng moment of inertia at the x-axis. Ang moment of inertia of y-axis is equals to the summation of moment of inertia of the y-axis, which is equals to 984 inch raised to 4. Ito yung answer. Ang problem number 5 natin is about the product of inertia. The question is, find the product of inertia of the channel section shown with respect to centroidal axis. Ito yung figure natin ng channel section. Ito yung mga measurements niya according sa coordinate system natin, x and y axis. Ito namang figure sa baba is pwede natin consider ang channel section na made up of 3 rectangles. Ito yung rectangle 1, rectangle 2, rectangle 3. Kailangan nating compute muna yung centroidal or the centroid of the composite section. Dito sa bar or sa tabular format natin, na sulat ko na yung mga or na-compute ko na yung mga data at isinulat ko na dito para organize siyang tingnan. Dito sa element natin, andito yung mga rectangle 1, rectangle 2, rectangle 3. Ito yung area I natin. Ito yung xi bar natin at ito yung y bar natin. At ito naman yung area natin times the xi bar. At ito yung area times yi bar. Dito sa rectangle 1, ang area natin is 15 times 100 is equals to 1.5. Dito sa rectangle 2, ang area natin is 15 times 200 equals to 3,000. Then dito sa rectangle 3 natin, 15 times 80 is 1,2. Dito sa xi bar natin, ang rectangle 1 natin is 50. Dito yung centroid niya. Then sa rectangle 2, 7.5. Dito siya. Ang rectangle 3 is dito, 40. Ang y bar natin is 15 divided by 2 equals to 7.5. Sa rectangle 2 natin is 15 plus 200 divided by 2 equals to 115. Ang measurement pala nito is mm. Dito naman sa rectangle 3 is 215 plus 15 divided by 2 equals to 222.5. Dito, ang area times the area I times xi bar equals to, dito sa rectangle, ito ay 50 times 1.5 equals to 75,000. Sa rectangle 2 is 7.5 times 3,000, 22,500. Sa rectangle 3, 40 times 1, 2, 48,000. So, ang total niya is 145,500. Dito sa area I times yi bar sa rectangle 1 is 7.5 times 1.5 equals to 11,250. Sa rectangle 2, 115 times 3,000 equals to 345,000. Sa rectangle 3, 222.5 times 1, 2 equals to 267,000. Ang summation niya or total niya is 600, or ang total ng area times yi bar is equals to 623,250. Dito naman sa area I, ang total or summation niya is 5,700. Dito, ito yung formula ng pag-compute ng coordinates ng centroid of a composite section. X bar is equals to summation or total of area I times xi bar over summation or total of area I. Ang total natin ng area I times I bar is 145,500 over total ng area I natin is 5,700. So, ang sagot niya is 25,000.53 mm. Na round off nito siya kasi 52.6 round off to 53, 25.53 mm. Dito naman sa y bar, ang formula niya is equals to summation or total of area I times yi bar over summation or total of area I. Ang total ng ating area I times yi bar is 623,250 over 5,700 is equals to 109.34 mm. So ngayon, ang coordinates ng centroid natin ng composite section is 25, x bar is equals to 25.53 mm. Y bar is equals to 109.34 mm. Ngayon, ang gagawin naman natin is i-compute ang product of inertia. Ito yung calculation natin ng product of inertia. Ito yung solution number 1. Ito yung dito sa next, ito yung I bar times I bar of xy or moment of inertia of xy I mm raised to 4. Dito, ito yung area I times xi bar minus x bar times y I bar minus y bar expressed in mm raised to 4. Dahil since ang rectangle has axis of symmetry, its product of inertia about the centroidal axis is 0. Dito, i-compute natin sa solution 1 or sa element 1 is 15 times 50 minus 25.53 times 7.5. Yung coordinates ng centroid of composite section natin, dito natin siya magagamit para ma-compute natin yung product of inertia. 109.34 equals to negative 3,738,037.2. Dito naman sa 2, 3,000 times 7.5 minus 25.53 times 115 minus 109.34 equals to 306,149.4. Dito naman sa 3, 12 times 40 minus 25.53 times 222.5 minus 109.34 is equals to 1,964,910.2. Ngayon, ito yung formula para makuha natin ang product of inertia of composite section about its centroidal axis. Product of inertia is equals to summation of product of inertia plus summation of AI times xi bar minus x bar times yi bar minus y bar is equals to 2,079,270 negative 2,079,276.4 mm raised to 4. Nakuha natin ito siya kasi inad natin or tinotal natin at ang kinalabasan is negative 2,079,276.4 mm raised to 4. Ito yung product of inertia natin. Negative siya. Problem number 6. Ang problem number 6 natin is about the mass of moment of inertia. The problem says determine mass moment of inertia of a thin rectangular plate with a thickness of 5 mm in which a semicircular portion is cut as shown in figure 10.11 about the base. The density of the material of the plate is 7,850 kg per meter cube. Dito sa problem na ito, kailangan muna nating i-calculate yung mass ng rectangular plate, which is equals to M1 equals to density 1 times area 1 times thickness 1. Ang density natin is equals to 7,850 times ang area natin is 0.1 times 15 0.15 times 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 Ang thickness natin is 0.005 centimeter equals to 0.58 0.58875. I-round up na natin siya sa 0.589 kilogram. Sa rectangle, sa semicircular plate naman is M2 equals to density 2 times area 2 times thickness 2 equals to 7,850 times pi times 0.5 squared over 2 for 2 times 0.5 times ito yung sa semicircular plate 7,850 times pi times 0.05 squared raised to 2 times 0.005 is equals to 0.154 kilogram. Ngayon, ikakalculate naman natin yung mass of moment of inertia. Sa rectangular plate, alam natin na ang mass moment of inertia of a thin rectangular plate about its centroidal axis is mass of moment of inertia 1 equals to mass 1 times h squared over 12. Therefore, ang mass moment of inertia of the plate about its base is ito yung mass moment of inertia of the plate about its base. Mass moment of inertia is equals to mass moment of inertia 1 plus mass 1 times h over 2 squared. M1 times h squared over 3. Then we put all the values that we get. 0, lalo na yung lagay natin yung mass ng rectangular plate. 0.589 times yung height 0.15 squared over 3 equals to 4.4175 or round up na natin sa 4.18 times 10 raised to negative 3 cube ay kilogram meter squared. Ngayon, ang i-compute naman natin is yung sa semicircular plate. Therefore, ang mass moment of inertia of the plate about the base of the composite section is ito na yung mass of moment of inertia natin. Ito yung answer. Yun lamang yung mga problems na nasagot ko. Sana naka-share ako or may na-impart ako na knowledge. Thank you for listening.